Alright guys, so to get more comfortable solving quadratic equations, we have to get very good at being okay working with square roots. So in example A through H, we're going to just practice simplifying and identifying our solutions from these steps. So in example A, I see 5 plus or minus the square root of 36. In this case, hopefully you recognize that 36 here is a perfect square. And so because it's a perfect square, we can simplify it out of the square root with pretty easily here. So guys, the square root of 36 is going to be 6. So in this case, what we have is 5 plus or minus, and the square root of 36 just comes out as a 6. So that's kind of nice. Once we get to this part of the expression, then notice how I have this plus and minus. I can separate the plus and minus to get 5 plus 6, and then 5 minus 6. And I can address each of these individually. So 5 plus 6 is 11, then 5 minus 6 is negative 1. And that's going to represent here, I'll just use the words two solutions here, 11 and negative 1. Now if I look at B is not going to be as nice, because if I look at the square root here, 24 is not a perfect square. So we have to be also be comfortable simplifying square roots that are not perfect squares. So to do that, we need to think about this square root of 24 and think of all the factor pairs of 24. So 24 is going to be 1 times 24, it's 2 times 12, 3 times 8, and 4 times 6. And I look at the different factor pairs, I want to now scan this list and try to find the largest perfect square. And so I have 1 and 4 are perfect squares, so I'm going to choose this 4. And I choose that because I can now simplify the square root of 4 to come out as a 2. So I can think about this question here and now think of it in a new way. I can now see it as 3 plus or minus the square root of, and instead of saying 24, I can now write in its place 4 times 6. And again, this is useful because I can now focus on the square root of 4. This piece, that's going to come out as a 2, leaving me with 3 plus or minus 2 radical 6. So I've now simplified the square root of 24 into 2 radical 6. Now in this example, I get stuck here in my solution, so I'll leave it as is, but I do have two solutions here, 3 plus 2 radical 6 and 3 minus 2 radical 6. But this simplification comes in handy with the quadratic formula because we're going to get used to seeing work like these, for example, down here. So we'll do one more together in this first video. In example E, I have negative 4 plus or minus the square root of 20 over 2. So again, this square root of 20 is not a perfect square. So I need to be able to simplify it by thinking about all the factor pairs of 20. So 20 is 1 times 20, 2 times 10, and 4 times 5. If I scan these different factors, I notice that 4 is my largest perfect square. It's just 2 times 2. So I can rethink this piece of this expression. Instead of 20, write it as 4 times 5. So now I have negative 4 plus or minus the square root of 4 times 5 divided by 2. Notice how this 20 is now written as 4 times 5. And this helps because now the square root of 4 we know is equal to 2. So now I can consider this question, minus 4 plus or minus 2 radical 5 divided by 2. At this point of the expression, I have three terms here, the negative 4, 2 radical 5, and 2. When all three terms have a common factor, I can divide by that common factor. So in this case, a 4, a 2, and a 2, I can divide them each by 2. Notice how I'm not going to divide or care about simplifying what's in the square root at this point. I only care about what's outside the coefficient. So here then, if I divide each of these by 2, I end up getting negative 4 divided by 2 is negative 2 plus or minus Then here, 2 divided by 2 is 1, so I'm left with 1 radical 5, or just radical 5. And then here, 2 divided by 2 is 1, so notice how in this case, that kind of goes away. So the simplified version of example E is negative 2 plus or minus radical 5. Again, the key here is that we need to simplify the original square root, and then if possible, divide a common factor, but only if all 3 terms have the same thing. If one of them is missing, then you cannot simplify any further. In this case, though, we could divide all of them by 2.